Hello, my name is Meagan Lydon. I'm a student at Embry-Riddle Aeronautical University. This is going to be a presentation of a data set from the United States Food and Drug Administration. The presentation will cover the following topics. I will introduce the data set, cover how I cleaned the data and validated the data set, the analysis and exploration process I went through, the data visualization methods and products that were produced from the data, the decision-making process, and the improvement strategies. The data set I used for this project was retrieved from the Food and Drug Administration website. It is a list of recalled products that are regulated by the FDA. The original data set was an extensive listing of recalled products that can be categorized as animal health, biologics, cosmetics, drugs, foods, medical devices, and tobacco. The data covered a time period from January 1st, 2015 to the present date. In the article, The Basic of Data for Analytics, Hunt explains that the overall goal of cleaning data is to have the highest quality data to start with so that there's a lot of confidence within the results. Data cleaning identifies incomplete, incorrect, inaccurate, or irrelevant parts of data. It then replaces, modifies, and even deletes dirty data. To clean the data set I retrieved from the FDA website, I first needed to import the XML file into Excel. I chose to only focus on food-related items so that I deleted all other listings from the data set. Then I decided that my goals and objectives were to focus on a specific time period, so I filtered the results and eliminated all listings that were outside of the 2016. After that, I modified inconsistencies while continuously validating the data throughout the process to ensure I have the highest quality of data to solve my business problem. This was my initial data set. As you can see, it is messy and does not have a lot of standardization to it. There are inconsistencies throughout the data, and the values are not all standard for product description. This is my final data set after I cleaned it. As you can see, I started by cleaning the date here. I filtered all out, so all I have is information from the year 2016. The next thing I did was I cleaned the data for the product description tab here. I created a more standardized value set so that the data can be easily filtered and sorted. Finally, I looked for inconsistencies within the reasons tab here to ensure that all data within a certain data value matched. Specific errors that I ran into were, for example, right here, the B is capitalized, where in the rest of the line items the B is lowercase. This created, if it wasn't fixed, issues within the visualization process. Now that the data is cleaned and in a usable format to satisfy our objectives, it can be explored and analyzed to discover potential problems and pinpoint possible trends. From the data set, I was able to discover 3 potential problems that the data could provide results for. First, how many foods were recalled in 2016 due to cross-contamination with a contagion? How many foods were recalled because they contained undeclared ingredients that could cause severe allergic reactions? And finally, what types of products were recalled the most? I was also initially able to use the data set to determine where or what information will require further exploitation within pinpointing trends. From there, I began the data visualization process. After researching several different data visualization tools, I was able to find DataPine. It's an online visualization software package that offers a free 14-day trial. DataPine allows users to connect a variety of different dataset sources to their applications and use them within their analysis tab to create a variety of different visualization products. After exploring a few options, I chose to create stacked bar graphs, column graphs, line graphs, and pie charts. The first visualization product I created was a stacked bar graph. I really created this product to represent the dataset as a whole. In addition, I used this product to discover where any trends were. The next two products I created were to answer my initial questions that I formulated in the analysis and exploration process. The first column graph shows that 245 foods were recalled due to cross-contamination with a contagion. You can also see that 150 foods were recalled because they included undeclared items within their food product. The next visualization product represents which items were recalled the most. As you can see, the top 3 recalled items were snack items with 113, produce with 53, and nuts with 51. In addition to answering the 3 main questions, I used the stacked bar graph to pinpoint trends that we may need to create other visualization products for. The 3 trends I was able to determine from the stacked bar graph were between May and June 2016, there was a significant increase in food items recalled due to listeria. In December 2016, there was a significant increase in food items recalled due to salmonella. And there is a continuous concern that companies are including undeclared allergens in their products. The first line graph represents foods that were recalled due to cross-contamination that can cause illness. As you can see, the incline in the gray line represents that there was a spike in listeria between the months of May and June, and the green line represents a spike in salmonella in the December time frame. The next visualization breaks out which types of products were recalled. The top pie chart depicts that the majority of products that were recalled due to listeria were either nuts or snack items. The bottom pie chart shows that the majority of items that were recalled due to salmonella in the December timeframe were either from the bakery or snack items. The next trend that was explored was the recalled items that contained undeclared allergens. The top pie chart shows that the most common products that contained undeclared items were snack items at 35% and bakery items at 19%. The bottom stacked bar graph shows that over the course of a year how many items were recalled because they contained undeclared allergens and what allergens ranked the highest. As you can see, nuts were the #1 ranking allergen that was undeclared within food products, with milk following second. Visualization products at this point can be passed to the decision makers so that they have more data to make better decisions. Overall, the dataset and the results that were produced can help the FDA identify how they can change their product standards and regulation guidance to minimize future occurrences. In addition, continuously monitoring for trends will help the FDA focus on potential live foodborne illnesses where they can alert health officials of potential breakouts. Finally, this presentation will cover improvement strategies for data collection, data quality, data visualization. An article from Tech Advisory highlighted data collection can be improved by doing 3 things: focusing on important metrics related to the data, reviewing customer interactions, and setting reasonable frequencies for collection and analysis. When focusing on important metrics, one might determine what insights the data might be able to provide and how the data will help answer the business problems. When reviewing customer interactions, you might ask who's using the data and how are they using the data. When setting reasonable frequencies for collection and analysis, you might figure out how often does the data need to be collected, translated, and analyzed. Relating back to the FDA dataset, they could improve their data collection strategy by setting reasonable frequencies for collection and analysis. They can determine that the data should be analyzed and translated at least once a month to determine if there are any trends that are occurring within recalled food items. An article by Gallo, 9 Tips to Improve Data Quality and Improve Decision Making, pinpoint that improvement strategies for data quality include creating, maintaining, and using a data dictionary, aiming for objectivity, and performing regular reviews of data to uncover anomalies. Using a data dictionary is basically determining what expected values for each data field should represent. Relating back to our FDA dataset, this would be ensuring that all the values within a specific data field are standardized. Aim for objectivity, categories in the data within the classification rules that are objective to the business problems. This could mean implementing a first and secondary product description column. So if the product description is bakery, what type of bakery product is it? Giving more detail could help harness more exact results. Finally, data visualization. Improvement strategies include choosing a chart that best represents the story, designing charts and graphs for comprehension, including a baseline when possible, and using accurate and visible labels. Do not over-label either. This is the end of my presentation. I hope you enjoyed it. Thank you very much.